मधुरभाषिणी सुखदां वरदां मातरं वन्दे वन्दे मातरम्. Thank you.
ధన్యవాదాలు జ్యోతిజీ. Now I request Vasudha Rani garu to do the prayers.
Yeah. Madam, am I visible? Is it okay?
Yeah, pardon?
Yeah, shall I start?
Yes, yes, yes. Please start the prayers.
Yeah. Oh, भूर्भुवस्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात्. ॐ विश्वानि देव सवितुर्दुरितानि परासुव यद्भद्रं तन्न आसुव. ॐ सहनाववतु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै. ॐ असतो मा सद्गमय तमसो मा ज्योतिर्गमय मृत्योर्मा अमृतंगमय. सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामया सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत्. गुरु ब्रह्मा गुरु विष्णु गुरुदेवो महेश्वर गुरु साक्षात् परब्रह्मा तस्मै श्री गुरुवे नमः. ओम शांति शांति शांति.
ధన్యవాదాలు Vasudha garu. Now I request our speaker of the day, Dr. Gautam Mukherjee garu, to take over the session and continue his Vedic mathematics class.
Sabiko namaskar. Namaskar to everybody. Today I start is continue with the Vedic mathematics class.
Gautam ji, one request is you just see that there is a lot of time for interaction also today, because many people want to ask some questions and all. Today being the last session,
Yes, sure.
Some people want to clear many doubts also. So you just keep in mind about that. Yeah.
Sure,
okay, thank you.
I will do this accordingly. I have a quick, I want to do quick revision of yesterday's session, and then today's divisibility class will start. Regarding the develop this online method, I told you, and I will in the last part I will show you the Excel sheet actually on which using which I can we can calculate all these things. We can calculate by hand by knowing this method, but actually you can also calculate Excel sheet. We also possible. So we come to that. I will just yesterday we did all these things, that how to make successive quotient and remainders in each case, and we have to only set that. We have to only know that what is the starting point and what is the digit divisor. So in case of 1 by 19, you start with 1, and it is 19 actually is it should be divided by 2. That you understand? Understood. Are you getting any echo?
No, today there is no echo. Today there is no echo.
Okay, fine.
Yeah, it is normal.
A normal monitor is given so that my sound is reaching. I to confirm that I did see. So you understand the thing, no? Suppose I write, suppose I do 7 by 19. What should the starting point? Or and with what I should start dividing? 7 by 19.
Oh, okay.
Only if you know the thing, and if you know the procedure, that successive quotient and remainder procedure, you'll be able to do it. So 7 by 19. What is the starting point? And what is the divisor? Digit divisor. It is 7, but we start writing after that. We say, divide. This is 19 means always 2. And 7 by 2 is 3, and remainder is 1. That way it starts. Similarly, 15. We start dividing 15 by 2. So as I told, instead of dividing 15 by 19, you have to divide 15 by 2, but with a special procedure. Okay. So I come to 29. Here see, again, suppose I do something like, I want, suppose 23 by 29. What should I do? I should start 23, but after 23, I write, we divide by 3, because for 29, the divisor is 3. 2 plus 1 is 3, or by this formula. So, I start dividing, and then you get like this in case of 1 by 29. Similarly, in case of 23 by 29, this is 23. So this is 23. We will start with, then I'll get 0.7931034482 and so on. And this is, you see 23 here. So likewise, you just see, and you'll be able to do it. One interruption. So in case of 23, you see here, could you find, look at it. So 23 by 29 will start from this 7931 and so on. So that is the idea. So suppose I do say 19 by 29. Same thing. You start with 19 and start dividing by 3. For 59, you divide by 6. Okay. So people are joining now, still joining. Now this is the algebraic proof I told you. This is the binomial expansion of 1 minus x to the power minus 1. And fully it is like that. And we are always following like this. Initially we divide by something, divided by that, in case of 19 it is 20, in case of 29 it is 30. I mean 3. I divide by 2 or 3, but automatically in background it is 2 is there. Now, after that, we just continue in the same fashion. That is it. In case of other D, what did I do? I'm just revising actually. What did I do? So that formula is applicable for something like 10n minus 1. So it is 19, 29, all ending by 9, 29, 39, and so on. You understand? Na? But how to make it work for some other than 9, it is doing. So what I have to do? So I have to multiply. If it is 1, you multiply by 9. If it is 3 in the last, you multiply by 3. If it is 7, you multiply by 7. Say 1 by 7. It becomes 7 by 49. I multiplied both numerator and denominator by 7. So 7 by 49. So then it comes to and amounting to this digit divider for 49 will be 5. 4 plus 1 is 5. So I start dividing like this, and it becomes 7 divided by 5 becomes 1, and remainder 2. So I write 21. This one, this way it goes. Okay. Similarly, 3 by 4, it is 1 by 13 becomes 3 by 39, and so 1 by 13 it becomes, start dividing 3 by 4. It is 0 and 3 and becomes 30. 7 and 2. 7 into 4 plus 2 is 30. That way it goes and it repeats afterwards.
Gautam ji, I have one doubt.
Yeah.
I am Babu here.
Yes.
Yeah.
No.
So I was doing, in fact, the homework that you have given. I was doing the last one. That is that 9 factor. So I mean 1, 10 by 21.
10 by 21.
So when
Yeah.
I was doing, yes, when I was doing that, I don't know. I'm getting stuck in the some part of the answer is correct and some part of the answer is wrong. So can you just do that? I mean,
10 by 29 will be quite challenging. Actually, as I told, this is the negative kind of
right.
negative kind of. Yeah. So
Can
I'll come to
you
that. I'll
put
come
it
to
on
that.
the?
Yes.
Yeah.
Yeah. I
Thank
agree.
you. Thank you. And few other questions also, I'm getting part answer correct and part answer wrong. So maybe
Yes.
there is some mistake I'm doing. I don't know where I'm doing the mistake.
It happens. It happens. I also did lot of trial and error in order to arrive at a particular one, so that I got confidence at least to give a lecture like this. I also didn't know anything. Achha.
No.
For in case of why I came to this negative, can anybody please tell? Why instead of this positive method, I was running like that? Why I had to come to that 1 by 29 a different method? Because I do not save anything. By the previous method, I have to write multiply in case of 137 ending. I have to multiply by 9, 3, and 7. In case of 1, I have to multiply by 9. It becomes very big. 1 by 29 becomes 9 by 189. So that digit divided becomes 19. So I wanted to save dividing by 21, but I arrived at dividing by 19.
Please.
Okay. You got the idea? I wanted to avoid dividing by 31, but I arrive at dividing by 28. It is so big because I multiplying by 9 because almost is the order of magnitude higher. Okay.
Right.
So in order to avoid that, the whole procedure is changed. Binomial expansion of 10n minus 1 by 10n plus 1 is considered. And we find that instead of plus, we get always a minus. The initial thing is fine. Something by say 21 I do, it is becoming dividing by 2. After that, it will always be minus. So that is the idea of 1 by 21. So 10 by 21 you told, no? 10 by 21 will be like this.
Yeah.
So you tell me, should I use a whiteboard?
Oh yeah.
10 by 21. So I basically do 10 divided by 2.
2.
Which is what is equal to 0.5.
50.
5 and 0.
Right.
So now this is the remainder. This is quotient. I told you that becomes actually negative 5.
Right. Negative 5. So minus 2, 1.
No, that is the thing. See, in the number line, on the number line, this is suppose 0.
Right.
This is minus 1, minus 2, minus 3, minus 4, minus 5. Okay.
Right.
Now, when I divide it, minus this 5. So, so actually, what in case of positive, what did I do?
It's 2 by 2.5.
So something falls here. So this is I divided by 2. So I get this much as the quotient. This divided by 2, of course, and this much what is remaining here I get as remainder, isn't it? This becomes remainder. what is left here, and that is always on this side.
Yeah,
So
why does it
similarly,
become, excuse me, why does it become -5?
huh?
Why does it be shown as -5?
-5 because it is 10 into remainder minus the quotient. So 0 into 0, sorry, 0 into 2, 2 is that 0 into 2 minus 5. So because of this -5, what is that? -5 is here. 1, 2, 3, 4, 5. -5 is here.
Yeah.
Okay. So actually,
Right.
but this -6 is divisible by 2. So we get the result -3.
Oh.
You mind it. Remainder is always positive. Quotient can be positive or negative, but remainder is always positive. That is the idea. So it becomes it is getting converted to -3 into 2 plus.
Oh.
So we get now -3.
Okay. -3
and remainder
0.
1. Remainder 1. This is -5
Okay.
is -3
Okay.
into 2.
Oh.
But
Okay.
this itself I got -3. So what will be my this thing? That 10.
47.
This is
Achha,
this is
10
1
plus-
becomes 10.
plus
10 minus -3 means 13. It becomes 13 now.
Okay.
Now it becomes 6 and
1.
remainder 1. But
And
6 becomes actually -6. When we
-6 is 4.
not for displaying here. I'll display here 6. Earlier I displayed -3 because this result was -3. But here result is now 6 and 1. The 6 I'll display.
Okay.
But when I do next one, I do 10 minus 6, which is 4. So 4 divided by 2 is 2 and 0.
And 0. And again minus.
Again -2. This -2 becomes -1, means 1 like this, 1 and this with the 0 here.
Okay.
But next time what happens? When I do it, next time division, I do what I do?
11. It is 0 again. One more.
It becomes 1. So it becomes 0.
Yeah.
And 1 a remainder.
Yeah. 1
This
remainder.
1 and 0 becomes again, I divide it, it becomes 5 again. That means
5.
Got it? 5.
0.
3 vinculum, 6, 2 and vinculum this and this one. 1, 2, 3. Oh, sorry, 0. 0. Yeah. So this 5, 3 becomes 4, 7.
What is 4, 7?
4, 7.
6, 2.
6, not 2.
2
and
19. 1, 9.
1, 9. And 0. You please use the calculator whether I'm correct or not.
Right. Yeah, it is correct.
So that is right. This is quite challenging. And in the Vedic mathematics book, it is very difficult. If it is written really, I don't know how people will understand. Vedic mathematics avoided this thing. I think they did some peculiar auxiliary function and so on, and then you do nines complement instead of this negative. What he is doing that nines complement. What is called Navataha. Navataha means nines complement, and Dasata means tens complement. So instead of this arriving at 3 bar or -5, you will do what will do 9 minus 5. You will do divide it by 4 and do some complication. Here I find it is very straight cut actually. Only you have to this mindset will be clear that okay, the way I am handling the positive numbers, it is in Vedic mathematics. I use the negative number in the same logic. As I told, When
I am
dividing
always
by,
free for
see,
you and
always your
Shashi.
remainder,
Because you guys don't occupy me, I am listening to all this.
see, in case of positive,
Andy?
I always get quotient and then remainder after that.
Now,
Remainder after that. Similarly, here you quotient, you are doing something here, you will get remainder after that. No, remainder should be always positive. Remainder should be always positive. So keep in mind, and then you will be able to do it.
This last 0.476, how did you get it? Just can you tell me again?
Oh, 5 and 5
5
and
is
it
2, 1.
becomes 3. 50 minus 3 is 47.
Okay, okay. Okay.
And 20 minus 1 is
Yeah, right,
19. Like this.
19.
So it's clear?
Right. Thank you.
This was very challenging, really. So it is
And
good that it is. Thank you, Mani. You tried that in the first class. This so these things will sometimes in between also will have a revision sort of thing. I want the Babuji or somebody I told any time you can get a slot for only for revision. In the meantime, people should have a lot of practice. So
they
if
should do
required,
homework.
I told him required.
Right.
Okay. Now this one, this is actually +1, and this I describe here, and here I gave an example. And see,
You
it
can
is saving
ask your
some.
doubt. You are unmuting. You please ask your doubt. You twice your no? Durga Garu, you please.
Please, hello.
I think she's not interacting. We'll just move ahead.
Achha. So similarly, for 31, you did like this, and for 51, we did like that. Started dividing by 5. 51 divided by 5, it will be 35. So 35 divided by 5, it becomes 7 and 0. But 0, 7, 0 again, this becomes -7. So it becomes -2 into 5 plus 3 is -7. So it becomes -2, and 3 minus 2 again. This becomes 32 basically. 32 again you divide by 6 and remainder 6. This 2 and positive 6 becomes 24 and divided by like this, and that it goes on like that. So in case of 35 by 51, which is actually basically 35 by 51 is how much? It is no 35 by 51 is nothing. Okay, it is okay. That way you have to go. Similarly, for 17 I can use it. I showed you in the next one. So in case of 8 by 17, you had a choice. Either you can express it as 56 by 119, or you can do 24 by 51. So for 24 by 51, it goes like this. And for 56 by 119, it goes start dividing by 12. 56 divided by 12 is 4, and remainder is 8. And that way it goes. And here it is state card, it is actually okay. So it is actually slightly should have been left. That can be done, but not required to be honest. This is actually the already 10th digit. Remember, this is this goes like this. So ultimately we arrive at 470588, but here is 47062. The 6 minus 2 becomes 58. So 8, 2, 3, 5, 5, 3, 1. The 3, 1 becomes 23, and minus 1 becomes 29. So that is the only difference in case of this one, negative method. Otherwise, it is all same. So I did some question exercise like this, and you do it. If you find too difficult, you just write for 5 places. First, at least 5 places, and in these positive places, you can do only for positive. You can have last 5 also. Please note down the only difference. Last 5, because it is coming from opposite direction. Last 5, how do you do? Here, actually, you suppose 17 by 39. You start with 17, means 7 and 1. So start 7 will be the last digit, but remainder 1, and start multiply by 4. So 7 will be the last digit, certainly. and 7 into 4 plus 1, 29. So 29 becomes the last but one digit. That way it goes. But in case of these negative ones, it is difficult to get last digits because this procedure is negative from the beginning. I could not still figure out how should we go about right to left or in case of negative numbers. But what is the negative? What is positive? Where is the end of negative positive? It's very difficult to understand. So I could not sit there. If I do anytime later, I will convey to others. Now periodicity, I told you that it is all 9 by this what is called repeat 9, being factors of repeat 9. That is the periodicity will be there. So that is shown here. So periodicity of say 73 is 8 because it is 8 numbers of 9 is divisible by 73 and 137, not below it, not below it. It may be divisible sometimes, but something below it also is divisible. The 37, for example, 37 is triple 9 is divisible by 37. Six numbers of 9s also will be divisible, but periodicity of 37 will remain and 3 because it is a minimum of we have to consider. So this table we went up to 50, but I displayed only here up to 20. Now I come to the today's topic. I'm sorry. It is about divisibility. Something divided, getting dividing by 10 means you will know always the powers of 10. I didn't write also, just to be here. Now, numbers, the number 2 and 5 are factors of 10. So, therefore, similar rules are there for 2 and 5. What is that? Divisibility of 2 to the power n requires last n digits to be divisible by 2 to the power n. Means that, what I told, that divisible by 2, it will last digit, only last digit it will be dividable. I do odd and even number. So divisible by 2 means odd and it is even number.
Right.
Divisible by 4, last 2 digits. Last 2 digits have to be divisible by 4. Similarly, 2 to the power n, suppose it is 2 to the power 3 means 8. I want to do divisibility of 8, so the last 3 digits will be divisible, has to be divisible by 3. In case of 16 to the power 4, last 4 digits. In case of say 64, something is divisible by 64. How to do? Last 6 digits has to be divisible by 4. Rest actually automatically takes care of this. Similarly, in case of 5 also, last digit is either 5 or 0. It is divisible. That means it is divisible by 5. Actually, sometimes we call is divisible. Even 0 is divisible. You know, 0 is called as divisible by every number. It is called. Yeah. Suppose 3 is divisible by 3, but 30 also will be divisible by any number of zeros also will automatically takes care. Now, what is that? I was saying. So here, yes, I was here. This one is divisible by 25 because last 2 digits, 2 to the power, this is 2 to the power 2. Sorry, 5 to the power 2. I'm sorry, 5 to the power 2. So last 2 digits. Similarly, suppose I divisible by 125. What should I do? How much?
Last 3 digits.
Last 3 digits. It is 5 cube. 5 cube. That way it goes. 625 last 4 digits and so on. Now, divisibility by a composite number demands divisibility by its factors. Say 42 will be divisible by 6 because it is divisible by 42 is divisible by 2 as well as divisible by 3. So it is divisible by 6 as well.
6.
So divisible 6 has 2 components, 2 and 3. 6 is multiplied by 2 into 3 is 6. So each of them is different formula, only 2 and only 3. So it will be divisible. 135 is divisible by 15 because it is divisible by 3 as well as divisible by 5. Now, divisibility by numbers ending with 1, 3, 7 to 9 has general method of osculation, which gets a trivial form in case of 3, 9, and 1. 3, 9, and 1 I discussed here very shortly, because divisibility by 3 actually it is coming from the same formula, but it is so trivial that it has taken a different form. In number is divisible by 3, with the sum of all the digits is divisible by 3. I think everybody knows all these things. Everybody knows. This is divisible by 3 because the repeated sum. I sum all the digits. Again, I may get a longer number. I again add all the numbers. Again, add all the numbers unless it finally gets to 24. It's divisible by 3. So all these numbers are divisible. 9. Number is divisible by 9 if the sum of all its digits is divisible by 9. Example, this is divisible by 9 because sum of all its digits in repeated sum ultimately come to 27. Again come to that 2 plus 7 is 9, so becomes 9. Again, this also 2 plus 4 becomes 6, and which is also divisible with 3. In case of 9, this is that. You keep on summing the numbers. In case of 11, it is the alternate sum you have to do. Since 9, 3, 4, 5, 7, 1 divisible by 11 because 9 plus 4 plus or odd position and even position. 9 plus 4 plus 7 minus 3 plus 5 plus 1 is divisible 11 and divisible by 11. So that way, find this exercise. You can note down the exercise and you can do it so that you check whether you understood. So I come back to here. So in case of 6, I find that it is last digit is 2. So it is divisible by 2. And 4 plus 2 is 6, which is divisible by 3. So it is divisible by 3. So this is divisible by 6 as well. That is the idea. So individually, I do for 2, 5, 2, 5, 3, 9, 11, etc. These were known. And by composite number, we do that. We knew from your textbook up to this point. But what happens when it comes to 7, 11, not 11, 11, 7, 13, 17, 19, all ending with 1, 3, 7, 5, except 3, except 9. It is like this. So for that, osculation method is there. What is osculation? A 2 or more digit number n is expressed in the form n is equal to 10r plus u. You just understand this thing. U is the unit digit and r is the rest of the digits. All 10, 100, 1,000, all clubbed to a rest of the digits. And this is, if we multiply that thing by 10 and add with that unit digits, it gives we get the number, isn't it? See, I say, for example, I do 139. What is that? 13 into 10 plus 9. A very big number, a few lakhs and so on and so on. So, suppose 5,274. So, 5,274, 5 to 7 into 10 plus 4 is that number, 5274. The idea is clear, isn't it? Then osculation breathing method to create a smaller integer, which is test integer. So I put it T, test integer, which is of the form this race digit. So see, race digit becomes less. A race digit plus that multiplication, that is called osculator. A multiplier plus the unit digit. So obviously it will be smaller. So instead of say 500, say 43, what I do as oscillation? Suppose I do oscillate by number 2. So it will be 54. I do oscillation with the help of the number. The multiplication is suppose 2. So I do 2 into 3. This is the idea. So the rest of the digits I take. Rest of the digits.
Please repeat the second part. I did not understand it.
Which one?
First part is clear. 543 is equal to 54 into 10 plus 3. After that, I did not understand.
See, 543 can be expressed as 54 multiplied by 10 plus 3, isn't it? This is basically 54 multiplied by 10, 540 plus 3, 543, isn't it?
Right.
So this is the race digit. This is this race digit I was talking of. This is the rest digit. 54 is my rest digit. This is the number n given. I have to test its divisibility by something. So here this is the rest digit 54. Except the rest means what? Except the unit digit. Unit digit is 3. This is 10 unit, 10, 100, and so on. I do not bother about what is 10, 100, and so on. Everything I call as rest digit. So 54 is a rest digit. So I form the test digit as 54, this rest digit, plus I am oscillating by 2. So 2 into 3. So it becomes 60.
Right.
Okay. So that is that. So this is the oscillation. This is the method is called oscillation. Again for 6, I do the same thing. 0 into 2 plus 6 is 6.
No, but for 54, why did you choose oscillation by 2?
No, I gave an example. I gave an example for not for 54. Suppose sometimes I require that oscillator becomes 2. Oscillator have to find no. So this is the deduction that how to find that m in case of a particular divisibility. This is an example I give him that I am oscillating. It is called oscillation of 543 with the help of 2. It means this
But
m.
how do we find that number to be asked?
I'm coming to that. This is basically this. I first gave the procedure that how to find the t. T is r plus mu. This is the example of a t. This is n. This becomes t. This becomes t. T is r rest of the digits plus this oscillator m into unit digit. Okay, where the multiplier m is called the oscillator. It is being said that the integer n is oscillated by m to get the t. The process can be recursive with the same oscillator. I can again continue with that same thing, same procedure. If I get multiple again that is divided into a unit digit and rest digit. Again I multiply the unit digit and add with the rest digit and so on. The unit digits t can be multiplied by m and added to the rest digit of that way. Oscillation is an efficient method for testing divisibility. It is a matter to determine required m. Given a number n and divisor d. Suppose I given a number n and d, I have to find that m. That how to find that m ending in 1. The d must end in divisor must end in 1, 3, 7, or 9. There is no point in dividing applying the procedure. Neither it can be applied. That applying something by even number or by a multiplication of 5. So it is only 1, 3, 7, and 9. The oscillator m can be found with the following consideration. I've got the division. So if you know some mathematics expression algebra, you will be able to understand. Otherwise, if you do not understand, they also I will tell you the procedure. This is the deduction. They just prove that how this procedure is working. So I consider m into capital N, that number minus 3. So it becomes m into 10. This is the n, 10 plus u, and minus this test. I told you that test is this r plus m. You can note down somewhere. N is this 10 plus u, and t is r plus mu. So m into n minus t becomes m into 10 plus u minus r plus mu, which is I subtract and so on. So mn minus t becomes 10m minus 1. This is the equation number 1. Now consider the case of divisibility in case of divisor d. We can find that find an oscillator such that the 10m minus 1 it should be divisible by d. The divisor, if we find such an m, such a multiplier, so that the 10 multiplied by that minus 1 is divisible by that number. So suppose I have to divide, my d is 3. D is, sorry, d is not 3, d is 13. I have to test the divisibility with the help of 13. Okay? Understood? Now, what is the multiplier of, you keep multiplying 13 with different numbers. I found that in one case, it will be just ending in 9. Ending in 9. Basically, it means that 10m minus 1 means what? 10m minus, oh, sorry, 10m minus 1 is divisible. So 10m minus 1. 10m minus 1 is some ending in 9, isn't it? This is of the form earlier we got in 19, 29, 39, 49, and so on. Now, what is the ending in what is the multiplication of 13, which is dividing in 9? It is obviously 39 multiplied by, because it is ending in 3, so I multiply by 3, it becomes 39. So my aim is this aim number multiplied is not 13 into 3, 39 doesn't matter. This 39 is 10 into 4 minus 1. So oscillator for 13 is 4. 4 is the oscillator for divisor 13. This is the idea. So because this is 39 is divided by 13, so obviously this will be dividing, and this I have to do, even then mn minus t will be dividing by. So if something is I try with this 39 oscillator and make it a t, so I get a t. If t gets divisible by 13, automatically n will be also divisible by 13 from the expression. There is some logic is there. Okay.
Can you give one more example?
I can give one more example. 7. Suppose I want to test the divisibility of 7. How much I should get multiplied? What is the multiplication of 7 which ends in 9?
7. 49. 7
49.
into 7.
So oscillator will be how much?
7 again.
No, oscillator will
Oh,
not be
49.
7.
Okay, 50 minus
5.
1.
50 minus 1. The 5 will be the oscillator in case of 7. So that is the idea. And if you like, we can come back to the algebraic proof actually. Algebraic proof we can just see, we just understand. Like when in the class, and I got some logic that the aim is not divisible. So therefore, these are actually referred to have a rigorous proof actually. So the logic has to be established. So that is the this part is okay. Now example. Suppose we case that was 343 divided by 7. First, we find the oscillator of 7. We see that 10 into 5 minus 1, 49 is divisible by 7. Thus, oscillator of 7 is 5. Once I found the aim, repeatedly I do. We execute the following process. 343 becomes 34, from 30 becomes 34 plus 3 into 5. 5 is oscillator. So this 3 I am multiplying. 3 into 5 becomes 49, which is divisible by 7. So 343 is divisible by 7. Take another example, big example. 64724. 64724 becomes 6472, raised digit, plus that unit digit multiplied by the oscillator with 20, so 64922. Again I do 649. This is the raised digit. But this was the first time test digit. In the test digit also I divide the test digit itself by raised digit and the unit digit. Unit digit I multiply by 5, becomes this thing, and it becomes 659. 659 becomes again 65 plus 9 into 5. It becomes 110. 110.
Excuse me, how did this 647 become 6492? Is it a typo error?
No, 6472 plus 4 into 5, 20. So it becomes 649.
Okay, fine.
649. And plus 2 into 5. 2 into 5 is 10. So 649 becomes 659.
Okay.
So that way it goes. It becomes more smaller, and gradually it becomes smaller and smaller. So it becomes very easy. At times becomes very easy. 11, not divisible by 7. So therefore, backtracking, we get 110, these, and ultimately 6474, none are divisible by 7. I give another example. Take the divisibility of this by 13. What do we do? Let us find the oscillator of the 13. We find that 10 into 4 minus 1, that is 39, is divisible by 30. So that aim in case of 13 is 4, and we do 11635 goes to 1163, this much I write, plus 5 into 4. This becomes a roll, it becomes different. This 5 is here, the unit digit, and 4 is my oscillator. 4 is the oscillator, so it becomes 20 again. So it becomes 1183. 118 is 118 plus 3 into 4 is 12, so 130. This is becomes, this is trivial. 130 you can see immediately. Oh, whenever it becomes obvious, then you just leave. If you know that 130 is divisible by 13, that you stop there. You don't have to do the last step. But that doesn't matter, you can do it also. Since it is 13, therefore 130, 100, 1183, 11635, all the backtracking, all these things are already divisible by 13. Divisibility of this number is by 23. 23, we find that 10 into 7 minus 1 is divisible by 23. 69 is divisible by 23. Isn't it? So therefore, 4, this becomes, we have to multiply by 7. 7 is the oscillator. So 4128 is here, 4128 is here. This 5 is this 5. 5 into 7. So this becomes 35. 35 is 28. 63. 4163. 416 plus 3 into 7 is again 21. You add with 16. This becomes 437. Again 43 plus 7 into 7 is 92. 9 plus 27 is again 20. Or 92 if we do 92, you know that it is 23. 23 into 4 is 92. I could have stopped it there. So therefore,
Right.
92, 437, all backtracking, all these things are divisible by 23. So that is the idea. So anything, you understand this?
Sir, how this 10 into 7 minus 1 come?
What
In
is
case
10
of
into 7?
it is in the divisibility by 23.
Huh.
How it comes, sir? 10 into
10
7
into
minus
7
1.
minus 1. 10 into 7
Yeah,
minus 1 is what? 70 minus 1 is 69. So something ending in 9 you have to find. So you have to, it is actually 23 into 3, divisible by 23. I told you that something you have to find where something ending in 9 will be divisible by the divisor, means 23 in this case. So 23 multiply with 3 to get 69. And 69 is 70 by 1. So therefore, 70 minus 1. So therefore, in case of 23, oscillator is 7. That is the idea.
Okay. Thank you, sir.
So I come to the next one. Positive, negative, and minimum oscillator. Sometimes it happens that, suppose say I have to find the oscillator of 41. It will be again the same logic that it will be in order to find the oscillator of 41. Oscillator of 41 will be how much? I find that 41 into 9.
Oh, 369.
369. The same thing, same logic as earlier we got. That is positive and negative method, 369. So oscillator, this is becomes 370 minus 37 into 10 minus 1, isn't it? There we called it Ekadekona Purve. Now here you are getting in a different idea, but same idea is same. So 41 into 9. So oscillator becomes 37. Very big number, and you have to keep on multiplying by 37, unit digit multiplied by 37, adding, it becomes very difficult. So what do you do? Negative oscillator. The same logic, same algebra applies. 10m plus 1 is divisible by d. All the algebraic expression hold good for oscillator minus m. When this becomes negative. T should be calculated as r minus mu in that case. In this case, minus m can be called a negative oscillator. Moreover, here some mathematically it is not rigorous minus positive, because in integer we call this plus minus. So it is for understanding purpose I wrote in this profession. Moreover, if m is oscillated to test divisibility by d, M plus minus FD also will be oscillator. See, for example, here I explain in this one that if 5 we got the oscillator for 5 we got the oscillator for 7. So 7 minus 5 minus 7 is equal to minus 2 is also oscillator for 7, because 21, which is 3 into 7 divisible by 2 into minus 2 into 10. Actually, basically minus 2 into 10, minus 21. Actually. Minus 21, which is minus 2 into 10 plus 1, means minus 21 is divisible by 7. 21. That way actually go here. You can do minus also. Doesn't matter what is the whole thing is minus also gets divisible. So here it said that again say minus 2, even 5 plus 7, 12. 12 can be also used as oscillator. But why to use when you can use 5? Unnecessarily, why to use 12? You can use 19 also in case of 7. 19 into 7. 19 into 7 plus 1 is, 19, 120 minus 1 means 12 into 10 minus 1, 119 is divisible by 7. I could have used 12 also, but why to use 12? I give the minus negative minimum one. No, either you could do it 5 or you can use 12 minus 2. In case of 41, I told I got you 37 into oscillator. So that in case of 41, see here also 41 minus 37 or whatever is 37 minus 41 is equal to 4. No, it is opposite. 37 is D M plus minus FP. So 37 minus 41 is equal to minus 4. Minus 4 also can be oscillator for 41. So 41. Here in this logic I get, but here also I can get like this. So in case of 41 itself, 4 into 10 plus 1 is 41. So this plus 1 is there, so this oscillator becomes minus 4. You remember that if this here is plus, then oscillator will be minus, and here is minus, that means oscillator will be plus. Oh. So I'll come back again to this one. So testing divisibility for 41 will be minus 4. Like for 13 we got plus 4, because 41 is minus 4. I continue with that some reading that if the M is the oscillator from something, F is an integer factor, plus minus this also will be oscillator. The oscillator whose minimum absolute value is called the minimum oscillator and most suitable for chosen for test division. In case of 7, I can even choose instead of 5, I can choose minus 2, because minus 2 will be easier to handle also. And moreover, it will be negative. All the time, instead of adding, will be subtracting. So 10 minus 5 is, or 10 plus, both are divisible by 7. So 5 becomes the minimum positive oscillator, minus 2 becomes a minimum negative oscillator, as well as minimum oscillator. In the positive side, 5, 12, 9 can be negative on the negative side, minus 2, minus 9, minus 16, all can be used for testing divisibility, but always we do with negative, minimum one. So here the table is visible, readable?
Yes, it is readable.
So here just systematically I did how we are getting actually. So I take any small n here on 10n. All the tens here, negative side, positive side, negative side, positive side. All these things are listed here. And in case of 9, the factors are 3 and 9. In case of 11, it is only 11. So 9 for 9 and 11, I don't know. For 3 and 9, we kept on adding because we do not notice it, because oscillator is 1. Oscillator is plus 1 in case of 3 and 9. oscillator is +1 plus 3 and 9. So unit digit adding, multiplying by 1, we do not notice that something is getting multiplied. We keep on, we just add it. In case of 3, 9, we added all the numbers, no? Added all the digits. How it is coming? Because oscillator is 1. Similarly, alternate, in case of 11, alternate digits we add and we subtract. It is always unit digit as if we are multiplying by -1, because oscillator of 11 is -1, and so it is automatic. So we are taught in the school level only up to this. In case of 9, 3 and 9, what to do? In case of 11, what to do? But beyond that, our schools never taught. In case of 19, it is positive, plus 2. This is plus 2. These are all +2, +1, and so on. Okay. In case of 19, oscillator is +2. In case of 21, oscillator is, or in case of 21, 7 on 3, oscillator is -2. Oscillator is -3. I could have written here. This is the n, and this is -n. I told no. It is minus. In case of
Playing this slide again. The previous slide was clear, but yeah, this one is a bit confusing. Please explain this one again.
1 second. Yes. So I consider all the numbers ending in 9 and all the numbers ending in 1. Okay, and I found that what are all the factors, including itself? What are the all the factors of that? Say 81 becomes 27, 9, and so on. But 9 is already there. In case of 91, 13, but 13 is already there here. 13 is already there here. So I have to use this one. So like this, I find that 39 is a factor of, so oscillator is 4 in this case, in case of 13. Because it is 39, 4 into 10, 40 minus 1 is 39, isn't it? Here I wrote 10's multiplier. 40 minus 1 is 39. So 39 is divided by 13 divides 39, or 39 itself divides 39. In case of 13 and 39, the oscillator is 4, positive 4. Whereas 41, it is 40 minus 1, so it itself is oscillator is -4, like this. Okay. 13. Here is oscillator is -13. Here oscillator is -13. Oscillator is -14. Oscillator is -15. Here oscillator is this +1 is 150, +15, +14. This is +11 oscillator, and so on. So 17, what is oscillator? 17 is 12, +12. But 17 into 3 is 51. 17 I can use, -5 also is oscillator for 17. This one, because it is on the positive side. I told you that is positive side means oscillator will be negative. Negative side means oscillator will be positive. It is the opposite. So you can make such a table. This is showing this thing. I don't have to write this. This table you can make yourself. Like this. You take 10's multiplier, 1 minus, 1 plus, and
The oscillator of 17 is -3 or -5?
-5. -5 is 51. No, it's 50 minus 50 plus 1, 51. So it is -5. 50. You have to consider this. Not by which you multiply. Ultimately, what the 10's multiplier plus or minus you get. That is important. Not which you are multiplying, isn't it?
Okay.
So here are more examples. Testing divisibility. So divisibility using negative oscillator. So testing divisibility of 2, 4, 2. Earlier we did by +5. Now you see by negative. We find that 21 is divisible by 7. So negative oscillator of 7 is -2. So we find that this 84291 -2 into 2 becomes 84287. becomes even quicker, it will collapse. 8428 minus 7 into 2 is 8414. Again, 841 minus 4 minus 2 is 833. That will finally goes to 77 is divisible by 7. So therefore, all backtracking, all these, all these numbers are divisible, and finally that biggest number is also divisible by 7. Note that for divisor ending in 1 or 7, it will be easier to use negative oscillator. Yes. Instead of positive oscillator. For example, in case of 21, it is only 10 into 2 plus 1, negative oscillator is minus 2, but its minimum positive oscillator is 19. I told you earlier. In case of that also, in case of that recurring decimal also, we face the same problem. In case of 1 by 21, whether we should divide by 19 or we should divide by 2 and with the negative method. So in case of 21, I could have gotten 29, we could have gotten 19 as oscillator, positive oscillator. Because this is divisible by 21, so we get like that. So both are divisible by 17. In case of 17, this is also divisible, this is also divisible. So whether we can use oscillator as -5 or plus. Here also you see that -5 plus 17 is 12, and again minus 2 plus 21 is 19. See, there is that relation is there. Mean this is this minus this means what? This minus this is this becomes positive. So 12 plus 5. When absolute value, you can, in case of one positive oscillator, one negative oscillator, you can just add their absolute values, and you will get the same number. 12 plus 5 is 17. Similarly, this oscillator of 21 was -2 and 19. So 19 plus 2 is 21. So you can see that. So suppose you by chance you get a positive oscillator, you want to find the negative oscillator. Simply you make it just subtract the divisor. You will get the negative oscillator, which is less than that. So you just this exercise you can do. You all got this PowerPoint presentation, no? From here you
Right.
you don't have to note down. So here you just do the exercise you do.
Right. This is an homework.
Yes, homework. Some more time is there, so I'll keep some time for revision for the whole thing, for question answer. So let me complete the course here. Now, this is very peculiar. So far we have done, it's called simple oscillator, simplex oscillator, you can say. But now I get multiplex oscillator. For divisor of the form 199, 299, 399, we could have taken oscillator as 20, 30, 40, and so on, isn't it? Because 199 plus 1 is 200, which is 20 into 10 plus 199 is 20 into 10 minus 1, isn't it? 199.
Yeah. Right. 20 into 10
199
minus 1
is equal to 20 into 10
minus 1.
Minus 1. Earlier we did.
Right.
Therefore, 20 is my oscillator in case of 199.
Right.
Similarly, for 299, 30 into 10 plus minus 1.
Minus 1, yes.
399 is 14 to 10 minus 1. So their oscillator could have been 20, 30, 40, etc. So now I do, instead of this simple oscillator, in these cases, we may also take 2, 3, 4 as multiplex.
Multiples.
Multiplex
oscillator.
Multiplex oscillator.
Right.
So this is called multiplex oscillator, and take 2 digits at a time. Let us say whether this number, let me again convert it into pointer option 10. let us check whether this is divisible by 299. Oscillator is 3, not 30, but oscillator is 3. Multiplex oscillator is 3. First, we write the dividend. I can have same algebraic proof. And if I try, I can do also 2 at a time proof. I can also make algebraic proof. But nevertheless, you know that it can be done. Need not do oscillator. So first, what we do? The first step is oscillator. When I do multiple oscillator, and I find that I'm giving with group of 2, this second order oscillator 3. We first write the division groups of 2 from right, mind it. If I divide this by left, 21, 96, 15, and 5, it will not do. You have to do by 2, 19, 61, and 55. First, you understand this thing?
Right.
So it was 2196155. From right, we group in numbers of 2. So first is 55, then again is 61, then 19, and then finally 2. It is 0, you can consider it 0 to also. So like this.
Right.
Now I do. So this number becomes 21961 plus 55. This is that time my unit digit, but it has 2 digits. 55 multiplied by that multiplex oscillator 2 order multiplier. This becomes this actually if I multiply, it becomes actually 22126. Just you 55 is 145. You add with this. Oh, sorry, 165. You add with this 165 here. Do you get this? Isn't it? You get it? 221. So please add 21961 plus 165. Is this one? Yeah. Then this becomes like this, and then 221 plus again 226 into 3. 78. So this 200, this one becomes 299, comes back to 299, which are obviously divisible, thus divisible.
It's divisible. Yeah.
See how quickly it is being done. So if I do by digit, one digit by one digit, how much it will take time? I keep on multiplying by, keep on multiplying by 30. 30 into 5, one get 150, and then it becomes this one. Ultimately comes, but it will be very one digit by one unit digit by one unit digit. So many number of processing you have to do. Here you number of processing became half, because with 2 at a time you are doing. So such a big number. See, imagine that such a big number, even dividing takes how much time? Very long time it will take. Dividing by 499. Here the my oscillator is how much? Is 5. It is 500 minus 1. So 5 into 100. Earlier we were doing for 10 minus 1. So my second order oscillator is 5. So I do again group by 2. The whole thing I group into 2. So this I didn't show in that another step could have been done to group by 2. This way. You group by 2, isn't it? From right. Oh no, I commit some mistake.
Yeah, there's a mistake here.
This one
69, 42, 87, 56, 66.
So this one. So out of that, I keep the rest of my digits until the last group. Here not unit digit, last group I should say. And this last group number, I just multiplied by its multiplex 2 order oscillator and come to this number. Again, I divide this number. So this becomes plus 87. This again I divide from right. So I get freshly you have to do. Sometimes it happens that it will be, may do
You
something
will
else.
miss. Yeah.
Huh? Huh.
You
So
may
again, freshly you have to divide.
Yeah.
The odd and even number will
Right.
change. This will not be done so easily. In the last, it will happen. So 87 into 5, again get this number. I divide it again by from the right. So this plus 25 by 5, I get this number, and finally get 499. That's okay.
Right.
So please repeat how we got in the second last row 10665690 plus 87 into 5 is equal to 10666125. So how is that 6125 achieved? Second last row 10666125.
That is 5690 plus 87 into 5. 5690
plus 87 into 5 is how much? So we got last one. Otherwise, all things are correct. 5690.
435.
And 87 into 5 is
435.
435. So 435. Yes. Isn't it? 6125.
That is correct only.
1066 is common. Now 5690 plus 87 into 5, 435 becomes 6125, isn't it?
Right.
Got it? Got it, madam?
Yes,
okay.
sir.
Madam, right.
Thank you. Thank you. 106661 plus 25 into 5 is 125. I just add it. I got it. 106786. 106886 in the. Oh,
again, yeah.
So there is something wrong here, no?
No.
1067 plus 8. This is plus is missing here. Okay.
Right.
So 1067 plus 86 into this 30 and
430.
430. And 430 plus 1067 is 1497. 1497 is 14 plus 97 is 599. Thus this is divisible. Clear?
Yeah.
Now I proceed. So now again, divisibility becomes multiple oscillator in case of negative. So here in case of 401, same thing is there, that multiplex oscillator of 2 digits becomes -4. It becomes -4. So I get the same fashion. Only do group from right, and keep on multiplying the last group by the oscillator, multiplex oscillator, and do these things, and all keep on doing like this, and it is not divisible finally. And this is divisible by this one. I do into this 6. This is the triple. So here, see, I go group of 3 I have to do. Okay. So see, I made it in the group of 3 like this. The idea is extended actually. So this 6 into 1000 minus 1 is divisible. This is the 5999. So is third order oscillator is 6 positive oscillator. So I do like this. So you see how quickly it collapses. See, big numbers. and collapsing like anything. So here also it is 7 into 1000 plus 1 is divisible by 1. So his oscillator is 7.
Yeah.
So this I group into this three I group. And in the last group I multiply by 7 negative, this negative oscillator, and this becomes this very quickly, and it is divisible. 0, if it is arrives to 0 means it is
Divisible.
either it should arrive to 0 or to that immediately you can look at that number. When I say either same number or look at that number and see, it will be very evident. Until unless that
Right.
you keep on do the processing. That is the idea.
Right.
Divisibility by I did quickly, but you just go to, I mean, this is the extension of that same order. Divisibility by rep 9 numbers. Multiplex oscillator of 1, group of right to group from right and add these things. 99 it is 1. Oscillator is 1 in case of repeat
Yeah.
9. So like in case of 9, I kept on adding everything. When a group of 1 only was there. We didn't notice that something you are doing. Here, this is a group by 1, this one, sorry, group by 2, and this is a group by 2 added. It is, this is divisible by 99. In case of 9, we also did divisible by 9, we just checked. Here is divisible by 99, we checked, and it is this one. From the last, we divided by group of 3. And it is divisible by 99, we'll make it divisible. This is, we make it group of 4. Say this one, 0, 4, this. And divisible by, this is 999, so divisible by 999. Because the oscillator is 1, plus 1. So in case of 1 or minus 1 oscillator, we do not notice it. Only that in case of negative 1, you have to, like in case of 11 we did. 11 we did, no? Minus 1, the oscillator is minus 1 in case of 11. Here is 1001. Give an example. We group 1001 oscillator is minus 1. Third order oscillator. So it is, we group it like this. Last one is positive, is negative. Doesn't matter actually, positive, negative. First one also could have made it positive. And this positive, negative, positive, negative, positive, negative. And finally it comes to 229, it is not divisible. Whereas these numbers, I slightly changed them, this thing, this 229, I assimilated somewhere, I had to make it 0.
But how do you decide this minus negative, positive?
Oh, oscillator is this, because see, 1000,
10 into 1000 plus 1.
1 into 1000. Okay, 1 into 1000 plus 1.
Okay.
Is 1001. So this is plus, so my oscillator will be negative. This is minus 1. So that's what called 1001. The oscillator is minus 1. In case of 11, first order is minus 1. In case of 101, this is the second order. When you have to group in the numbers of 2, the second order oscillator is minus 1. In case of 1001, in case of 10,001, tell me what should be the oscillator and how much order? 10,001. It's fourth order oscillator. We have to group in group of 4, and my oscillator is minus 1 because it is 1 into 10,000 plus 1. So oscillator is minus 1. That's why it goes up. So divisibility by either that repeat of 9, 10,000, 9999. Suppose we get 9999. 9999. What is the oscillator? Its fourth order oscillator should be plus 4. And in case of this 10,001, fourth order oscillator is, sorry, not plus, I'm sorry. fourth order oscillator is +1. But in case of this fourth order oscillator is -1. This is the order. In the grouping order, the grouping order to do. So in case of the -1 means it will be always negative. In case of 11 we did like that, no? In case of 11 we did positive, even position, odd position. Similarly here also, odd group, even group, odd group, even group, like this. And we add, and then finally it comes to 0 and 0.
Do we understand? 1 minute. This last number, previous screen.
Huh?
This 524, 476, 648 divisible. Have you put alternately negative, positive, or is there any method?
No, alternatively do positive, negative. Doesn't matter. I could have started with 524 and -476, something. But normally the thing is that we always take care of this thing from. Doesn't matter. Doesn't matter really. See, if I suppose had we arrived at -229 here, suppose I put a plus opposite, it would have gotten -29. Doesn't matter. -29 is we could have said yes, it is not divisible. Either remainder is coming as -29 or +20, doesn't matter.
So we can choose our own way, either +524.
Yes. It is liking only.
The two questions. Firstly, we have to start putting my plus minus from left side or from alternative or from the right side. And the second question is, what if the digit, is it possible for this method if the digits are not divided completely in a set of 3, means like had it been ending at 452 instead of 45, so the 452 could not have been made, one digit less than the number of digits available. So is the method only if the digits are divisible by like in this case 1, 3, 6, 9, 12, 15, 18, there are 18 digits. If there were 17 digits, then could we use this method?
Yeah, why not? It could be like this one also. Suppose it's not there. The same thing. I could have divided. In that case, it will be again 500 less. It will not have been divisible. But its procedure will be applicable. Yes.
Okay, sir. It means grouping has to be started by the rightmost digit. Right?
Grouping has to be started by writing. Right. But the sign may not be there. Sign may not. You may not start from right. But at least since you are grouping, you are doing right. So you will be liking to do plus from the right. Actually, it doesn't matter. Here you can put negative.
Okay, sir. And sign has to be started from left.
Either way.
Minus sign has
doesn't matter. Doesn't matter. I could have done plus, minus, opposite. But as we could have
done it the other way too. We could have done plus 524 minus 476 plus 678 minus 716.
Yes. Certainly. It will arrive to the if it is 0, it will be 0. But if it is something, say 229, it will be minus 229. Doesn't matter.
Yeah.
But grouping must be done from right. You cannot do, suppose this 5 was not there. You could not have grouped like this 224, 766, 487. Then you would your procedure will not work. Finally, you arrive at last. There will be only 201. It is not possible. So you have to always group it from right side. Okay.
The last 5 minutes are there.
Okay. So here multiple oscillator others. Suppose I want to do by 429. I find that 421 into 19 is 799. I do not have time to find how we will find. It is by trial and error, but actually there is some procedure. There is a long procedure. So third order oscillator is 8 in case of 421 also. It was for 799, but all the factors of 7999, all the factors of 729 also will have the same estimator, provided smaller is not there. But even smaller is there, there can be smaller oscillator, but 8 will remain as a oscillator. So similarly, here 2 lakhs 1. So in case of 409 as well as 489, the fifth order oscillator is -2 because they are factors of this number 2 lakh 1. So 10 to the power 2 10 to the power n plus 1 and 10 to the power minus n plus 1. Something into. Suppose m into m is oscillator. M into this thing or m into this thing. In this case,
Gautam, how much time will it take?
it will not take. It is last. This is the last slide. This is the last one.
Yeah, sure.
So you can note down. Just have a note down. You write like this. I didn't write here. In case of a multiply m into 10 to the power n plus 1 is divisible by a divisor. You wrote it?
Yeah.
So the nth order oscillator for the divisor will become minus m. Maybe that I will write it and send it. You can note down, not point. Sometimes you have to will also participate. Sorry, not minus 1. Not minus 1. Minus 1. This is positive. I mean, I don't write anything. I only write it.
Is divisible by divisor, then
the nth order oscillator of the divisor becomes minus m because it's this side. Now again I write m into 10 to the power n minus 1. And in case m into 10, this I'm now considering this one. In case of m into a multiplier m into 10 to the power n minus 1 is divisible by a divisor, its oscillator becomes plus m. So here minus means here plus.
Plus.
And here plus means here minus. So like the 7 into 10 cube. Oh, sorry, 8. 8 into 10 cube, but 8,000 minus 1 is 7,000.
Right.
So its third order means 10 to the power 3. Third order oscillator is plus 8.
Plus
Here it is
8. Minus 1, so plus 8.
Here the fifth order oscillator, because 2 into 10 to the power 5, 2 lakh. 2 into 10 to the power 5 plus 1 is divisible by 401. So therefore, the fifth order oscillator of 401 is minus 2.
Minus 2.
So from the right, you keep on dividing, group by 5 and divide, multiply by 2 and subtract from the rest one, and it will be test of divisibility will like that. Okay. And doesn't matter how big is the number, but immediately it will be collapsed to small number. So here also the same logic applies. 229 and oscillator is 3.
In fact, the bigger the number, the slower the collapse.
The faster it will collapse when it is the order is big. Order big means it will be collapsed in the groups of that much.
Right.
Okay.
Okay, Gautam ji, we'll have another revision class again. I think you can just, if it is completed now, we'll.
Completed. It was the last slide.
Thank you very much. Everybody was very interested with the Vedic mathematics. On behalf of Veda Samskruti Samiti and Sanaatana Dharma course, all our students, we thank you, earnestly thank you for your wonderful sessions.
Welcome.
I think we will have one more revision session, as you said, and I think everybody can get more
If so required, if demand is there.
so
Yes.
required.
Hi,
And
hi.
also the assignment,
Namaskar.
whatever has
Namaskar.
been done, they can do it. And I think they can also post it in the WhatsApp group if they have any specific queries to be cleared from
Right.
Dr. Gautam ji. That would be
Moreover,
very
my
good.
number is there. My number is given there, no?
Yes, yes, yes.
Right,
Yes,
right.
that is good. Okay, we'll conclude. Gautam ji, can you just close the presentation? Yeah,
You
and
can
then
note down my number.
yeah, please
Right.
note down his number. Yes.
9830239722.
Yeah. You can this is a WhatsApp number, so you can do WhatsApp also for small doubts and so on. I'll keep on. But
can I
please
ask a
request
general
that you
question
do homeworks.
about Vedic mathematics?
Huh.
Sir, sir, why should actually I mean, what is that thing that pulls somebody towards Vedic mathematics? I mean to say that today, whenever I want to do some multiplication or anything, my fingers immediately go to the calculator or computer, and it becomes a a simple this thing. Similarly, the children. Because when they work, they have to write the steps also in their exam or in their this thing. So they have.
That is the thing. So this has to be in national level. Vedic mathematics should be accepted as a valid valid alternative.
Okay.
So we always see we should not say that the school level teaching of plus multiplication, division, addition, etc. is the best efficient one. How should anybody claim? There can be alternative methods for different from elsewhere it is found. And moreover, as I told, suppose today you will find that people have forgotten. They claim that they have forgotten mathematics. They don't know about that. And somebody discovers some procedure, a shortcut procedure. Somebody and may publish a paper also. This happened. Somebody published a paper on this. That multiplication. From rightward 1/19. Only whole for 1/19 or divisible by 19 is a paper was published, and this was accepted also because they didn't know that this work is already done. It is already there in Vedic mathematics.
Yes, sir. You told about that. Right.
So, but this thing, I'll tell you one more thing. It is told that even calculator or computer, if sometimes they use the logic of the Vedic mathematics, it is found that the calculator or computer also becomes faster. Because see, as you see, suppose it's divisibility, some calculator is also computer is asking about the divisibility of this thing, and they are doing the conventional division. It will take much more longer time in the computer proceeding. No doubt the computer or calculator is very fast, but even then, if the logic is the Vedic mathematics logic is taken there with some logic, and immediately it will be very faster, even faster that the calculator. The processing time very important sometimes. Processing time of a computer will reduce in many cases if it is Vedic mathematics also is applied there.
Correct, sir. Correct, sir.
Gautam
Sir,
ji,
what
I
should
have one question.
sir, what should
Gautam
one? I mean, what is that pulling factor of the Vedic mathematics that actually, if I mean, that will pull me away from the calculator whenever I have a question, it will pull me towards it. So, I mean, what are such things that I will think of that? Okay, let me do it with Vedic mathematics, so that will improve my. So, that was my. I mean,
See, nowadays in this all this mechanical and instrument culture, we became too much dependent upon them. As a result, we are not exercising our brain adequately. Adequately. See, because I can give him the example that earlier people walking was the only method of going from here and there. So nowadays, what is happening from small places, they are using scooter, car, and so on. And so they have to do a walking exercise. People tell, okay, doctor will tell that you please walk. So what is happening? It is that we are got dependent upon some instrument, and we are not working. Similarly, it applies to brain also. So these alternative methods, you are learning the alternative methods and exercising on that. You'll be confident that I can do with my brain also. I can do independently something. Now, suppose a big task is given, you use computer on calculator.
Gautam, I have one question. Somebody like
I think we'll have to.
Hello. Somebody like NASA, ISRO, in their space launch and all that, are they using Vedic mathematics? If not, why?
Which one?
Somebody scientific, ISRO in India, NASA in USA, are they resorting to Vedic mathematics for their launch calculations?
That we cannot say. But actually, see, method, see, Shakuntala Devi, all heard in the name of Shakuntala Devi.
Yeah.
In the 60s, 70s, she actually defeated computer, that time computer, not today's computer. But anyway, it was very fast. See,
did she use Vedic mathematics?
Maybe something, some procedure. See, even Vedic mathematics is a open-ended thing. Actually, it is. You will find that it is written in that book. It is actually intuitional mathematics. So these are the procedure. As an example, it was told to you. But actually, when you get to too much intuition, you will yourself generate procedures.
Yeah,
so
Gautamji,
mathematics
sorry.
gives you the way it welcomes devising newer and newer procedures. See, Shakuntala Devi did 23rd of root of a big number, say about 12 digit.
Gautamji, please, sir,
Yes.
time is out, and a lot of people are waiting out, and we have one more session for clearing the. Sorry.
Okay.
Sorry
Let
for
us
interrupting.
conclude for the day, and thank you, Gautam ji, for your wonderful session. We'll continue it in the next this one also. Okay. Huh?
Yeah.
We'll just
Next what?
Yeah. Thank you very much.
Yes.
Yeah.
now
Thank you
I
very much.
request our Vasudha ji to have the prayer. Then it is Jyoti ji.
Thank you so much, sir.
Vasudha ji, your prayer.
No. I'm here.
Yeah.
Same prayer, huh?
Right? Yeah.
What I had sent you yesterday, you can follow that. You just tell whatever.
Yeah, 1 minute.
If there is a problem, please let us know.
Yeah. CC Babu Garu, you can just tell the prayers. I think it's taking like. Yeah, you please.
Prayer, I am not ready, madam. Yeah.
Anybody
So
else?
somebody.
Yeah. Yeah. Yes. I think Vandana ji, please. You can unmute yourself.
त्वां वेति शत्रुदहनेति च सुन्दरेति भक्तप्रियेति वरदेति सुखप्रदेति विद्याप्रदीप्तगहनेति च ये श्रुवन्ति तेभ्यो गणेश वरदो भवने त्वमेव आत्मा त्वं गिरिजामति सहचरा प्राणा शरीरं गृहं पूजा ते विषयोपभोगरचना निद्रामाधिस्थितिं संचार पदयो प्रदक्षिण विधि प्राणी सर्वा गिरो करोमि तदखिलं शम्भुराराधनम् कारुण्यदोषोपहतः स्वभाव पृच्छामि त्वां धर्मसम्मूढचेता यच्छ्रेयस्यान्निश्चितं ब्रूहि मे शिष्यस्तेऽहं शाधि मां त्वां भवन्तु। धन्यवाद।
Namaskar. Dhanyawad.
Okay, thank you. Jyoti ji, the national anthem. I request all to stand and sing the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभाशिष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद।